Now the general complex solution of the dynamical system x dash is equal to ax is given by x of t equal to c1 v into e power lambda t plus c2 v bar into e power lambda bar of t. Okay, in complex eigenvalues we can take in this format. Otherwise in the general real number systems, okay, in the real number eigenvalues we can take c1 v1 e power lambda 1 into t plus c2 v2 e power lambda 2 into t. In whenever you get that eigenvalues are real numbers, then the general solution we can write in this format. But whenever you get the complex eigenvalues, the general solution of the given dynamical system we can write in this format. X of t is equal to c1v e power lambda t plus c2 into v bar e power lambda bar of t. That is the difference between real number system and a complex number system while writing the general solution. Now substitute the corresponding values. So then you will get that x of t is equal to c1. We did not get that value, so it is right. So you can write that value as it is c1 into capital V value is that eigenvector 1 minus I into 1, and exponential power lambda value is minus 2 plus I into t plus c2 value and v bar. V bar means 1 minus I will become 1 plus I. Okay, and 1 as it is. Exponential power lambda bar. Lambda bar is nothing but minus 2 minus I. Here we have lambda is equal to minus 2 plus I. Whenever you apply that bar, minus 2 minus I will become. Okay. Similarly, we have capital V is equal to 1 minus I 1. Okay. Whenever you apply that bar, V bar is equal to, so 1 minus I will become 1 plus I. So 1 is t 1 as it is. Okay. So in that format we can write the values. Next, where c1 c2 are any complex numbers, to obtain the general real solution, rewrite the vector v e power minus 2 plus I into t as, okay. So real solution means, for in this general solution, you can observe clearly, in this general solution, to obtain the real solution, so for this vector we have to rewrite. Okay, so in that format, so capital V into e power minus 2 plus I into t is equal to capital V value as it is, this value exponential power value, so we are separating. So therefore e power minus 2t plus I into t, so we are multiplying with t. Okay, so therefore after multiplying we are separating that powers. Okay, so therefore e power minus 2t into e power it, and capital V 1 minus I into 1, e power minus 2t value as it is. Here e power it is there, e power I into t. So therefore you know very well the formula, e power I theta is equal to cos theta plus I sin theta, cos theta plus I sin theta. From that formula we can write e power I into t value also cos t plus I sin t. Now rewrite that value cos t plus I sin t into capital V value 1 minus I into 1 and remaining value exponential power minus 2t. So multiply with this trigonometric function with that vector. So here we have one row and one column. Then you will get the multiplication. So you have to multiply this row with this column. So cos t into, so here you have in this format, cos t plus I sin t into 1 minus I. This one is the first row value, and the second row value same cos t plus I sin t into 1. Okay, cos t plus I sin t into 1 you will get in this format. Okay, so this one is the matrix. Here I wrote directly that value. So how we can write that value I am explaining here. So next, in the next step, you can multiply this cos t with that bracket. So okay, cos t into 1 cos t minus I into cos t plus, again here second term is there, I sin t. For that value also you can multiply, then you will get the value I sin t. I sin t into 1 I sin t only. Here I sin t into minus I square sin t, minus I square sin t. Remaining value is cos t plus I sin t. So this one is the resultant value. In that format we can write this value. Okay, so clearly cos t minus I cos t plus I sin t plus here I into I square sin t. The second row is cos t plus I sin t into exponential power minus 2t. Now simplify again. So cos t minus I cos t plus I sin t. I square is nothing but minus 1 amma, and already minus is there. So minus into minus you will get plus. So therefore plus sin t. So therefore, and the second row is cos t plus I sin t into exponential power minus 2t. Here you have constant only angles only, cos t and sin t you have, so write them at one place, and from the second words take small I common, from these two terms take small I common, then you can write it as in the complex number format. Okay, so the next value should be in this format. So LHS is equal to V into exponential power minus 2 plus I into t equal to cos t plus sin t, we can write 1 pair plus, so from the remaining two terms if you take I common, so then sin t minus cos t, and the second row is remaining value is as it is cos t plus I sin t into exponential power minus 2t. Here you can observe that the value is in the complex number format amma. So if you imagine this total value as small a and plus this total value as b, so okay, a plus bi, the second row value also in the a plus bi format only. That means we have real parts, we have imaginary parts. So now you can separate that the real part and you can separate the imaginary parts with respect to that exponential function. So you can separate one matrix with this real part amma. Those two column values are the real numbers. Next you can separate imaginary part values. Imaginary part values means these values. Okay, these two values are the imaginary part values. So therefore you can separate them. V into e power minus 2 plus I into t is equal to real part is cos t plus sin t and cos t exponential power minus 2t plus I into imaginary part remaining values minus sin t minus cos t and sin t exponential power minus 2t. So therefore the general real solution of x dash is equal to ax is given by, so these are the, we can write in this format, x of t is equal to c1 into cos t plus sin t cos t into exponential power minus 2t plus c2 into sin t minus cos t sin t into exponential power minus 2t. So this is called the real general solution of the given dynamical system. Okay, so where c1 c2 are real numbers, c1 c2 are definitely real numbers, the total system is real number only, that's why we are calling it as a real solution. And previously we have that the complex solution. Okay, so this is called, okay, whatever this mentioned box is there, so the total solution is called a complex solution. Why? Because where the constant c1 c2 are the complex numbers, to get the real solutions, so we can take that vector value and we can decompose that vector into real values. So in this format we can find the real solution and complex solution for the any dynamical system. Next, second question of this problem is find the shapes of the trajectories. So here, since the eigenvalues are capital lambda, okay, lambda is equal to minus 2 plus or minus I, those are the eigenvalues. Here you can observe that lambda is equal to minus 2 plus I is one value and same minus 2 minus I is the another value. Two complex eigenvalues are there. Then the trajectories are spirals. You know very well from the properties of the eigenvalues, we can say that whenever you get the complex eigenvalues, the nature of the trajectory is travel towards the origin in the spiral format. Okay, so the then the trajectories are spirals. Okay, on this diagram you can clearly see here. So this point is the center. This center is called a spiral point. Whenever you get complex eigenvalue, so the resultant origin that has some relation with the trajectories, that origin is called spiral point. Okay, real parts of the eigenvalues are negative. Okay, so here real parts are nothing but this value sum. In this eigenvalue, real parts is -2. Imaginary part is +1. Here nothing is there means +1 and -1. Okay, real part of the eigenvalues are negative. So the spiral tends toward the origins. ఎప్పుడైతే మీకు కాంప్లెక్స్ నెంబర్స్ లో రియల్ పార్ట్ అనేది నెగిటివ్ వాల్యూ వచ్చింది అనుకోండి, ఆ ఆరిజిన్ చుట్టూ మనకు ఫామ్ అయ్యే స్పైరల్స్ ట్రాజెక్టరీస్ ఎలా వస్తాయంటే మీకు స్పైరల్ ఫార్మాట్, ఇక్కడ డయాగ్రామ్ మెన్షన్ చేశాను కదా. సో ఈ ఫార్మాట్ లో అన్ని స్పైరల్స్ అనేటివి మనకు ట్రాజెక్టరీస్ ఇట్లా రౌండ్ గా తిరుగుతూ ఉంటూ మనకు ఆరిజిన్ దగ్గర మీట్ అవుతాయి. ఓకే, టెన్స్ టువర్డ్ ద ఆరిజిన్. Then this origin is called a spiral point. Whenever all those trajectories travel towards origin and meet at one place, then that origin is called spiral point of the dynamical system. That is the shapes of the trajectories. E problem ki, okay, based on the eigenvalues, based on the complex eigenvalues, the nature of the origin is spiral or spiral point. The shapes of the trajectories are spirals. So మనకు trajectories ఎలా ఉన్నాయంటే spirals వస్తాయి. For example, in the previous lecture only clearly discussed that lambda we got positive values and negative values. Eigen values మనకి ఎలా వచ్చాయంటే 2 values వచ్చాయి. One value is lambda is equal to -1 వచ్చింది, lambda is equal to 6 వచ్చింది. Whenever you get 2 positive and negative values in one matrix, then the shapes of the trajectories are saddle points. Okay, మనం ఏమని చెప్తామంటే saddle point అని చెప్పాం ప్రీవియస్ లెక్చర్ లో. shapes of the trajectories are arc the trajectories అని చెప్పేసారు అనమాట. ఆ ట్రాజెక్టరీస్ మనకి ఏం ఫామ్ చేస్తాయంటే saddle point అనే ఒక ఆరిజిన్ ని ఫామ్ చేస్తాయి. అంటే they are attraction towards the origin. Okay, so they are attract towards the origin and repels from the origin. Okay, repels from the origin. These types of origin is called saddle point. Whenever you get positive negative eigenvalues, okay, this phenomena takes place. Whenever you get the only complex eigenvalues, spiral point will occur. Okay, so this is the difference between the complex eigenvalues and real eigenvalues. If you get only real eigenvalues, that too positive, okay, that too positive, then you will get that attraction. Okay, so whenever you get eigenvalues less than 1, lambda values, eigenvalues, the magnitude of that eigenvalues less than 1, then attraction, origin is called attractor or attraction. Whenever you get the eigenvalues positive values only and greater than 1 in magnitude, the eigenvalues are positive values and greater than 1 in magnitude, then repeller, that origin is called repeller. You know very well about those topics also. So why? Because here we have some situation regarding those points only. We are discussing the 4 definitions of the trajectories of the nature of the origin. Okay, so these types of problems are very very important in the examination purpose amma. So మీకు వచ్చిన eigen value యొక్క eigen values నుంచి ఒకవేళ రియల్ eigen values అయితే 3 పాయింట్స్ ఉంటాయి మనకు. కాంప్లెక్స్ eigen values అయితే ఓన్లీ 1 పాయింట్, అది స్పైరల్ పాయింట్ అని చెప్పేస్తాం. అవి కొంచెం గుర్తు పెట్టుకొని వెళ్ళండి ఎగ్జామ్కి వెళ్ళేటప్పుడు. So it is easy. Okay, so this is the total explanation of this lecture. So I hope you understood this lecture very well. In the next lecture we are coming with next topic. So make a perfect practice, prepare well. Until bye, thank you.